Next.js? Firstly, let's look at the official definition. Next.js is a React framework for production. Next.js gives you the base developer experience with all the features you need for production: hybrid, static, server rendering, TypeScript support, smart bundling, root prefetching, and more. Low config needed. The ecosystem around Next.js is very thriving. In my opinion, Next.js is a very powerful React framework, and it can be regarded as a static site generator, automatic static optimization framework, and serverless framework used for building a Jamstack application while Next.js app is deployed on Vercel. Essentially, Next.js is a tool that can help people develop better websites more effectively. So, what can it really do for us? Is it necessary to you? To answer the above questions, it's necessary for us to know a brief history of developing websites. At the very early stages, if we wanted to see a new web page in the browser, we needed to send the right URL request to the web server, and then the web server would send the right rendered HTML file to us. Later, after some client rendering, we could see the new web page in our browser. However, in this way, the web page is very slow and not flexible to users. If there is a little change happening in the web page, users have to change URL and ask the web server for a new HTML file. In general, the website in that period was too static to do something more. So, how about getting something new on the web page and not changing the URL at the same time? People came up with an effective solution called server-side rendering. In this new approach, if we wanted something new on the web page without changing the URL, we just needed to send a PHP request to the web server, and then the web server would talk with the database to get some necessary data. Later, the web server would render a new page for the user. At last, we could see the new page rendered by the web server without changing the URL. To be honest, it's a huge breakthrough for dynamic web development. However, there were some new questions. Firstly, for the web server, the process of receiving needed data from database costs a lot of time. The communication between web server and the database happens very often. In other words, before the final rendering operations, it costs a lot of time of the web server to collect relevant data from database. Secondly, the process of rendering web page on web server also costs some time. In general, although SSR contributes a lot to the development of dynamic web page, it still needs to be improved from the perspective of saving time. There was also a new technology called AJAX, which means asynchronous JavaScript and XML. AJAX just uses a combination of a browser built-in XML HTTP request object, which is used to request data from a web server, JavaScript, and HTML DOM, which is used to display or use the data. AJAX applications might use XML to transport data, but it is equally common to transport data as plain text or JSON text. AJAX allows web pages to be updated asynchronously by exchanging data with the web server behind the scenes. This means that it is possible to update part of a web page without reloading the whole page. Let's look at the workflow of AJAX. Firstly, an event occurs in a web page. The page is loaded, a button is clicked. Later, an XML HTTP request object is created by JavaScript. and then the XML HTTP request object sends a request to a web server. Next, the server processes the request, and then the server sends a response back to the web page. Later, the response is read by JavaScript. At last, proper action like page update is performed by JavaScript. Thanks to the new language JavaScript, AJAX also contributes a lot to the development of interactive web page. Later, people wanted the web page become more interactive and dynamic. But it's difficult for the traditional server-side rendering to accomplish it. There was also a problem to web developers. While developing a web, there are too many languages, so it's difficult to master and manage them all. So, based on that, PHP was ditched. More and more JavaScript frameworks like jQuery came out. Those JavaScript frameworks make it even more convenient to update a web page dynamically using JavaScript and fetch data using AJAX. From that time, web developers started to get used to writing most of their code on client-side. Then the time of client-side rendering came. There was a new concept called single-page application. That means a web page just sent one request to the web server to fetch the initial HTML, and then every update to the page afterwards was done with JS and AJAX, instead of completely reloading the page. Now, let's talk about a real working process of client-side rendering and single-page application. If the user clicks something functional on the web page in the browser, there will be a request sent to the web server, and after some authorization operations, the web server will send initial HTML file to the browser. Later, on the one hand, there will be some communications between the client side and JavaScript frameworks via the internet for AJAX data fetching. On the other hand, there will also be some communications between client side and server side to get the needed data from database. Then, the rendering will happen in client side. At last, users will see a new web page with the content we want. Compared with traditional server-side rendering, using client-side rendering spends less time on rendering and contributes to developing more complex web apps in a more convenient way. However, as web development became more complex and search engine optimization emerged, the main drawbacks of client-side rendering became more and more obvious. Time costly. As the demands of modern web apps became more and more complex, the process of client-side rendering costs too much time. Go back to the workflow of client-side rendering. With client-side rendering, the browser just receives a nearly blank HTML page and then starts to communicate very often with both servers and frameworks. At the same time, there will be a series of operations like downloading JavaScript, executing JavaScript, making DOM manipulations through JavaScript. Those operations are really costly, especially when the hardware devices are not as powerful as expected. Poor SEO. SEO means search engine optimization. Search engines like Google have special programs called crawlers, which crawl the web by starting with a curated list of web pages, then following all the clickable links from those pages, and then following the links from those pages, and so on. Eventually, they will reach every part of the public web. Based on that, it's difficult for a search engine to get useful information from a client-side web page because search engines just get nearly empty HTML pages with some script tags back from servers. Although the search engine can simulate a real browser where all the scripts will be run and get the final visible page to scan, the whole process is costly and error-prone. As the complexity of Webpage increased and the popularity of SEO, using server-side rendering would cost less time and get better SEO. But did web developers need to write PHP again? Of course not. There was a new technology called Node.js, which allows a web server writing in JavaScript. At the same time, ecosystems around NPM were thriving. It's easier to use so many powerful open-source JavaScript libraries both in the browser and the server. Also, thanks to Node.js frameworks like Meteor, the line between client-side rendering and server-side rendering got more blurry. With no server-side rendering, the browser sent a request to the web server firstly, then the first rendering will happen on server side. Later, the rendered new web page will be sent to the browser. On the client side, if there is a lead, there will be some much lighter client-side rendering, which could be regarded as client-side hydration. As more useful techniques like lazy module loading, code splitting, and bundling was introduced, the performance of new SSR with client-side hydration improved a lot. In general, at that new stages of SSR with client-side hydration, web developers could write all code in JavaScript, use popular JavaScript frameworks like React, and render initial web page mostly on the server. At the same time, there were some problems. SSR with client-side hydration was a little difficult to accomplish. SSR with client-side hydration was not common enough. Not all pages contain dynamic data that requires a web server to read from a database. Most pages could be static. We don't need a complicated web server to host our pages. We just need a separate API server that the static HTML file can make its request to. Based on the above questions, it was necessary for us to change the existing server. The new workflow of getting new web page in the browser will look like this. If a user clicks on something on the web page in the browser, then there will be a request sent to the file server, and then the file server will send relevant HTML file to the browser, and then there will be a series of operations like downloading JavaScript, executing JavaScript, making DOM manipulations through JavaScript. Later, to get more useful data, there will be a request sent from the client side to the API server. And then, after some communications between API server and backend server, the API server will send JSON file to the client side. Later, after the final client side rendering, user can see the new web page as expected. According to the above workflow, if we want to cost less time, we need to make mostly all of HTML files static. We need as many static pages as possible. To emphasize, static pages doesn't equal to motionless pages. Static pages can load scripts on their own, containing complex JavaScript and CSS. And then the scripts part can do dynamic stuff to the page. In the above case, we want to make as many static pages as possible on the server side, and then load functional scripts as fast as possible on the client side. In fact, the common page load sequence is fixed. Firstly, the browser needs to receive the relevant HTML file from some server. Secondly, there will be dozens of scripts and style sheets loading and tons of optimizations to make them all load super fast. So, in the above approach, how to speed up the first step of page load sequence. In other words, how to get relevant static pages from server as fast as possible. There was a new technique called called CDNs. They are cheap, global networks of machines that are heavily optimized for storing static files around the world. If we could make sure that all of our web pages were static pages, and then we could leverage CDNs to cheaply distribute our web apps around the world, making it readily available to users. In general, as a web developer, we store static files on CDNs, and as a user, we get those stored files directly from the closest CDN very quickly. There was also a technique called browser cache. If a user has visited a page, the static file will be stored in the browser cache. When a user visits the page again, if the existing static file is up to date, the closest CDN will return 304 not modified, and then the browser will directly use the existing static file, which is stored in the browser cache. With CDNs in browser cache, a web page's loading sequence now looks like this. If a user wants to see something new in the browser and click on something, firstly, the client side will check if the browser cache already has relevant rendered static file. If there is, the browser will send a request to ask the CDN that if the existing version is the newest, and then the CDN will return an answer. If the answer is right, the browser will use the existing one, and then there will be some communications between the client side and JavaScript frameworks with the internet for AJAX data fetching. Also, if there is a lead, the client side will send a request to the API server to fetch data. Later, after some communications between API server and backend server, the API server will send data, maybe in the form of JSON, to the browser. At last, after some simple client-side rendering, the user will see the expected web page. In general, CDN and browser cache technologies are the primary tools to ensure that the initial static file response is returned as fast as possible. Also, there are some other techniques such as prefetching, preloading, pre-connecting, SWR, font and style sheet inlining, service worker caching, and some others that make page load fast. Now, if we want to further optimize the page load sequence, we need to, for the page on our website, which is 100% static, we need to make sure it is available on a CDN as a static HTML file. For the page on our website, which has dynamic functionality, we need to try our best to make as much of the page static as possible. Based on the above optimizations, the static parts of web pages on our websites can load almost instantly with the help of CDNs, browser cache, and related techniques. At the same time, the dynamic parts can be enhanced by fetching the relevant data from new server side. As web developers, what can we do to accomplish the above optimizations conveniently? Next.JS can help us effectively. It can help us to make as much of the web pages static as possible and produce CDN-friendly static output for pages that are 100% static automatically. By looking back at the history of developing web pages, we have learned the killer feature of Next.JS, that is, automatic static optimization. So, how does Next.js implement this ingenious feature? Firstly, let's look at the Next.js folder. Inside of a Next project, you have a page directory where each JavaScript or TypeScript file defined here exports a React component that represents a root in the application. In other words, the file structure here mirrors the actual URLs that the user will navigate to. For example, hello is associated with hello component and can be navigated using example.com API hello URL. Now, let's look at data fetching and fetch functions in Next.js. Firstly, look at the official definition. Data fetching in Next.js allows you to render your content in different ways, depending on your application's use case. This includes pre-rendering with server-side rendering or static generation, and updating or creating content at runtime with incremental static regeneration. First of all, let's look at static site generation and getStaticProofs function in Next.js. According to the official definition, if you export a function called getStaticProofs from a page, Next.js will pre-render this page at build-in using the proofs returned by getStaticProofs. At the built-in of an Next.js application, this function is used to pre-render static file, which will be distributed on CDNs later. It can fetch data from database like heterogeneous CMS, and this function always runs on server and later on the client. In development, getStaticProofs will be called on every request. Let's look at the workflow while using this pre-render approach. Firstly, the developer has written a Next.js application and then deploys this app at some server. During the build-in, getStaticProofs functions inside the pages will fetch relevant data from database such as heterogeneous CMS. After receiving needed static proofs, some static pages will be rendered at server side and then transported to CDNs in the form of HTML or JSON. So later, if a user clicks on something in the browser to get a static page of the above Next.js app for the first time, the client side will request the closest CDN, and then the closest CDN will give the existing static file to the browser. After receiving the static file, the browser will save it in the browser cache to make reusing this file conveniently, and then if there is a need, there will be some client-side rendering. At last, the user will see the expected webpage in the browser. Now, let's look at server-side rendering and getServer-side-proofs function in Next.js. Also, according to the official definition, if you export a function called getServer-side-proofs from a page, Next.js will pre-render this page on each request using the data returned by getServer-side-proofs. This function runs at request 10, and the developer uses it only if you need to pre-render page whose data must be fetched at request 10. If you do not need to pre-render the data, then you should consider fetching data on the client side. Let's look at the workflow while using this pre-render approach. As you can see, the static site generation part doesn't change. To emphasize, while the Next.js app is deployed on the server, getServer-side-proofs function, which takes the charge of fetching data at request 10 and generating pre-rendering page, will be ready to work. Now, if a user clicks on something in the browser to get a new page which isn't a static one, the client side will send a request to the server side. After getting the request, the server side will fetch useful data from database, and then it will pre-render the new page. Later, the new rendered page will be sent to the browser. Also, if needed, there will be some client-side rendering. At last, the user will see the expected new page in the browser. Now, let's look at the final approach to fetch data in Next.js. Incremental static regeneration in Next.js and getStaticProofs function, and revalidate_proof and getStaticPath in Next.js. According to the official definition, Next.js allows you to create update static pages after you build your site. Incremental static regeneration enables you to use static generation on a per-page basis without needing to rebuild the entire site. With ISR, you can retain the benefits of static while scaling to millions of pages. To use ISR, it is a revalidate proof to get static proofs like this. First of all, let's look at this function. As you can see, it's a getStaticProofs function which gets called at built-in on the server side. What's more, it may be recalled on a serverless function because of the revalidate proof. By using the revalidate proof, Next.js will attempt to regenerate the page when a request comes in at most once every 10 seconds. In general, with that, Next.js can regenerate these pages after timeout in the background. But if there are no requests to a given page, there's no regeneration. Here's how it works. For this Next.js page, the timeout is 10 seconds. When user A clicks on something in the browser to request this page, the existing static file, which was generated at built-in, will be served. Set the moment of receiving the first request from user A as a start, and then there is a special period 1 whose 10 is 10 seconds. During period 1, all requests from all users will get a result of original static file. After the period 1, if there is a new request, the original static file will be served again. Also, this new request works as a trigger which will cause the Next.js to generate a new version of the page in the background and update the static page for future requests. We set this period as period 2. Later, when another request comes in after the regeneration is done, the updated static page is served. We set this period as period 3. It will always be fast because users will always get a static response. Secondly, let's look at this getStaticPath function. When a request is made to a path that hasn't been generated, Next.js will serve a rendered page on the first request. Future requests will serve the static file from the cache. Okay. Finally, I hope this video is helpful to you. If you like this video, please give me a like and subscribe my channel. See you next time!